Hello and welcome to POWTECH Virtual Talks. Today we are talking about Food Goes Powder. And Dominik von Gebrüder Lödige Maschinenbau is talking about single pot systems, one machine, various possibilities. Empower yourself and join the talk.
Warm welcome from my side as well. First of all, I would like to introduce myself. My name is Dominik. I'm the head of the Life Science Technology Department here in Lödige. The Life Science Technology Department takes care for all projects from food, pharmaceutical, and cosmetic industries. As you maybe know, Lödige is a supplier of horizontal mixing systems, but also about supplier of drying systems, of granulation systems, of coating systems. So we are really a supplier of process technology solutions, and process technology is a key word for my presentation because the title is Single Pot Systems, One Machine, Various Possibilities, and this refers directly to process technology. And I would like to start with a question: what is a single pot system? A single pot system describes a machine which is capable of carrying out different process steps within one system. Typically, a single pot system is basing on a horizontal or vertical type of mixing system. It's maybe important to mention all slides I'm going to show here are, of course, basing on horizontal mixing or single pot systems because Lödige is a manufacturer of these, but everything is also valid for vertical systems, like, for instance, our colleagues from Amexon are doing and will show most likely in the next presentation. Typical process steps which we can run in a single pot system are mixing, liquid addition, granulation, heating, cooling, chemical reactions, and vacuum drying. And at the end, particle size reduction or milling processes. I will refer to all of these process steps in the next slides in more detail. And starting with the most important process step, which would be the mixing. Typically, horizontal or vertical mixers are the core from a single pot system because they ensure proper movement of particles of product within the system, which is crucial for all further process steps. Independent from the type of mixing system, typically we're talking about mixing homogeneities in a range of 1 to 100,000 and higher for a wide range of products. In best case, to avoid any product segregation, like Mr. Barnico just showed. And as mentioned before, the mixing elements ensure a proper and perfect product movement in the machine and are hereby really very important for all other process steps. So you can really say that the mixer is the core of the single pot system. Maybe just to show in a very easy way how the mixing works, product is typically fed from the top by gravity, mixed, and then discharged by gravity. Yeah, this is as simple as this. Let's have a closer look on the liquid addition. After we run a dry mix or a pre-mix, there are various possibilities for adding liquids to the product. This can be added by using vessels and pumps. It can be added by pressure vessels. Liquids can be sprayed onto the product bed. They can be injected into the product bed. They can be added into the range of choppers which are installed in the machine and distributed in the mix. The purpose of liquid addition can be various. It can be for granulation, which will be one of the next topics here, but it could be also used for flavoring, for coloring, for triggering of chemical reactions, for particle coating, for API addition, and many other things. So whenever we need to add a liquid phase to a dry mix, this can be done as liquid addition step. The logical following step after you added the liquid is very often the granulation step. And as you can see here on the right side, there are many different possibilities how you can combine particles to a granule. Typically, or working for 14 years for Lödige, I think I've seen all of this happening in a machine, but typically we are looking to these kinds of granulations where you are granulating the particles with the help of a liquid binder. Of course, you can have also sinter bridges or magnetic or electrostatic forces. You can get form closed bonds, but typically on purpose, you're trying to reach this. The granules are formed in the machine by shear forces and interactions between particles, mixing elements, and drum. Also here you see the mixing itself, and the mixing elements have got a fundamental meaning also for the granulation process. The main purpose of granulation is increasing the product's flow and dosing characteristics and to decrease dust and product separation. So this goes a bit into the direction from what Mr. Barnekow mentioned in his previous presentation. Of course, it's nice if you don't have to granulate, if you can save the step, but in many production steps, or production processes, it's needed to increase the product characteristics. Yeah, there can be multiple reasons also why you have to do a tempering of the product. This could be heating, this could be a cooling. Reasons for this could be maybe a drying process. It could be to trigger chemical reactions. This could be to sterilize product and different things. And typically in a single pot system, you do this by a heated jacket around the machine and or heated mixing elements. This can be heated with hot or cold, with hot water, or chilled with cold water, or it can be heated by thermal oil, steam, molten salt, or other things. And very important is typically you've got, if you have a look to the right picture here, you've got the heat transfer surface. You've got the heat is transferred into the product, and what would typically happen is that you get a layer of dry product on the wall, and to avoid this, you have to move the products. And also here, the mixing elements have got a fundamental meaning because they ensure a proper exchange between the product particles and the heated wall. So at the end of the day, you've got a uniform heated and dried product. What you see here below, this is a thermal image we did during an FAT from a customer's machine to prove the uniform heating of the machine. Don't worry, the machine is not glowing. It's just heated. It's just a thermal imaging, but to show a uniform heating of the complete machine is possible. Besides the heating by a double jacket or the cooling by a double jacket, it's also possible to inject directly a steam or liquid nitrogen into the machine in case you want to have a blast chilling or blast heating. Now, this could, if you have to freeze something in the machine or if you want to sterilize something, this might be beneficial. This is also possible. Chemical reactions are very often the result of adding heat to a system or adding a kind of liquid, which triggers the reactions. The chemical reactions in a single pot system can take place at vacuum, they can take place at ambient pressure or at overpressure. All is possible. Typical reactions you may run in a single pot system are classical acid-base reactions, like for effervescent tablets. I showed here on the right side a typical reaction with sodium hydrogen carbonate and citric acid with addition of water, which you all know from these nice bubbles from your effervescent tablets. I will have a case study at the end of this presentation giving you more details about this. It's just an example, but there are further processes possible in a single pot system, like the alkalization of cacao powder, chemical synthesis of cellulose derivatives, polymerization reactions, and more and more and more. After a liquid addition, a granulation, maybe a chemical reaction, typically a single pot system is used for drying as well. And as I've showed previously, the systems are equipped with a temperature control jacket. Typically, they are built vacuum tight as well, because what we're looking for in a vacuum drying process is to have fast evaporation times and very often also to evaporate moisture and liquid below the boiling point at atmosphere temperature. This is, for instance, here the boiling curve for water. What you see here, typically it would start to vaporize at 100 degrees C at atmospheric pressure. And the more you lower the pressure, the more you drop with the evaporation point. And what we're typically looking for is in a range, let's say between 10 and 100 millibar to have an evaporation of liquid at low temperatures. If a single pot system is equipped for vacuum drying, it's basically looking like this. You see, it's basically still a mixer, but this mixer is equipped with a temperature control jacket around. In this case, it's also equipped with a heated main shaft. It's equipped with a vacuum-tight filter to separate vapors leaving the machine from particles. So typically we've got filter cartridges in here, which are cleaned by pressure bursts. So basically, it's a vacuum-tight heated mixer. This contains the advantage of a gentle drying at low temperatures, especially for heat-sensitive products like hormone products, homeopathic products, vitamins. Typically, we've got very high evaporation rates due to the driving forces from the vacuum. And the vacuum drying can be also very or contain a lot of benefits if you have to handle oxygen sensitive or explosive critical products, because without an oxygen atmosphere, it's very easy to be handled in the machine. Yeah, a typical setup for vacuum dryer is not only the dryer itself. Typically, we need also a kind of vacuum system. What I'm showing here is a typical setup for a vacuum drying process. So you've got the single pot system, then you've got the vapor stream leaving the single pot system, passing a condenser. In the condenser, we are separating the moisture from the exhaust airstream and collecting this in the tank. And the air is leaving the condenser towards the vacuum pump. Typically, we are using liquid ring pumps because they are very robust and they are even able to condensate small remaining amounts of liquid within the pump. Last but not least, also a particle size reduction, respectively a milling can take place in the machine. And we can differentiate between choppers and mills. Choppers are directly mounted in the machine, while a mill can be mounted on the outlet. As you can see here, there's different types of choppers available, different blade sizes and shapes depending on the product. We also have rotor stator systems, which are somehow like a mill, which can be installed directly in the machine. And typically they're used for breakdown of lumps, cracking of color pigments, granule size adjustment, distribution of liquids, and so on. Very important, the number and the design of the choppers is customized according to the machine size, according to the process and to the product. It's just a picture showing how they can be arranged in the machine. So they are sidewise installed. Here you can see also a number of choppers really in a bigger machine. Yeah. Milling, here we are sheeting a little bit because the mill is not directly part of the single pot processor because it's added on the outlet, but I think it's still a smart idea. In this case, you see a single pot processor, in this case a 1600 liter machine, where we have got a conical shaped mill directly mounted or installed on the outlet. So the product, when it leaves the machine, it's directly milled before it's conveyed by vacuum conveyor into the customer's container. Showed a lot about possible process step. Now let's have a look to an animation, how a process could look like. And by the way, this is not just an animation. This was in fact is basing on a machine or on 6 machines which have been supplied to a customer in Ireland. We start with a simple mixing process of the raw materials. Afterwards, we start a liquid addition process, in this case with 2 fluid spray nozzles from the top. We are adding a liquid to the premix and starting to build up granules in the machine. After the granulation is completed, we heat up the machine in the main shaft and we pull vacuum to dry the granules. We evaporate the moisture, and afterwards the granules are discharged in a dry way. This would be just an example how a single pot system could look like. I would like to summarize my previous slides with the question, why using a single pot system? The major benefit is really the reduction of several machines to one machine. If you consider you may need a mixer, a granulator, a dryer, and a mill, and you can have all in one machine, this leads to less machine investments, less required installation space, less maintenance and cleaning efforts, a higher product yield because you're not losing any product when you fill or transfer the product from one machine to the other, and you require less staff. Then it contains a good possibility to process toxic or high potent products because you can do all the process steps within one closed product chamber. And as mentioned before, typically you've got a vacuum drying process which contains a lot of advantages for heat sensitive products or critical explosion or oxygen critical products. I talked a lot about what's possible, and I think case study is better than 100 theoretical slides. So I would like to show you two quick case studies about installed single pot systems. I would like to start with the 1,600 liter machine for the manufacturing of effervescent tablets and granules. I'd like to start with the chemical process. I showed this already on the previous slide. It's a very easy chemical process. You're starting with a kind of carbonate, and with an acid, you're adding water, and what's happening then is you generate carbon dioxide, which makes nice bubbles. Yeah, and you may know this from home with baking soda and vinegar. When you build a volcano or something like this, it's the same effect. And this is what makes the tablets bubbling in your glass. And the idea is now we do a granulation in our single pot system. We start this chemical reaction, but we interrupt it by a rapid evaporation of the liquid. And this is possible by heating it up and pulling a high vacuum, because we want the chemical reaction to take place in your water glass and not in your single pot processor. But we still need to granulate the product because otherwise we can't press it to a tablet. So if you have a look to the production process, starting with the mixing of dry ingredients, we're adding a liquid, run a granulation. Hereby we are starting a chemical reaction. Then we interrupt the chemical reactions by evaporating the liquid. Afterwards, we run a cooling step in the machine. We do a milling, and then a final blending with flavor, colors, and lubricant can take place. Then it can be packed directly in small bags, or it's going to a tablet press. And in fact, these are the steps we run on a Lödige single pot system, showing you how the installation looks like. In this case, 1,600 liter machine is installed with the integrated black and white separation. So we have here the production room, here's the technical area. We've got the sieve mill installed on the discharge. We've got a vacuum conveyor for pneumatic discharge of the system. We've got 2 liquid addition nozzles for adding the liquid from the top for the granulation and the chemical reaction. And not to forget, we've got a lot of peripheral equipment which is installed in the technical area, like the lubricant supply systems, the vacuum system, WRP systems, the controls, the pneumatics. Also having a look from the back side, you see additionally we've got 2 choppers installed for granule size calibration. And in this case, we've got a special filter with a sidewise installed port for removing or changing the filter elements because we were very limited in height here. I know I'm short in time, so I'm going to rush a little bit the last 2 minutes. I want to show you a second quick case study. In this case, it's for 200 liter single pot system for high potent hormone animal health products. And I will start immediately with the production process. In this case, a customer had a process where we start, of course, with the mixing of dry ingredients. Then we run a liquid addition granulation process, a vacuum drying at low temperatures because the hormones are very temperature sensitive. Afterwards, we run a milling process before it's blended with lubricants and then transferred to a tablet press where the customer is pressing pellets, which are finally used for the treatment of cattle. In this case, we do the mixing, the granulation, the vacuum drying, and the milling in our system. And this is how the installation looks like. Again, you see we've got the machine integrated into a pharmaceutical wall to have a clear production and technical area separation. This small thing in the middle is the actual single pot. If you have a look, single side supported, so you can easily access it from the front. We've also a liquid addition system with pump, flow meter, granulation solutions, preparation and storage tanks. This all belongs to the same system. Maybe one thing to highlight here is the machine is prepared for single-use glove boxes. So what you see here are frames where the customer can install these glove boxes in case he needs to open the machine or he needs to change the filter. By this machine, we could replace a ribbon blender, a tray dryer, and a standalone mill with one system. So we could reduce 3 systems to 1. And we've got a complete contained process. So the customer could completely avoid full protection suits for filling, discharging the machine, and so on. Maybe also worth mentioning, we had a lot of peripheral equipment installed in the technical area, which you don't see on this picture here. Maybe on my last slide, just to show also the single pod systems can be quite complex systems, and they need also, besides the system as a process technology, they need also a tailored control system. And just to get an idea how this could look like, of course, it's basing on a PLC and PC. It's 21 CFR Part 11 compliant and flexible for complete automation of the complete unit with all peripheral equipment. I know this was a lot of input. I hope it could give you some useful information, and I'm happy to answer your questions right now. Thank you very much for your attention.
Thank you, Dominik. And there are quite a few questions in the chat, and I think we start right away because time is giving us a bit of pressure. So thank you for the interesting speech. And Jürgen Böcks is having a question in pharma powder processing. Just 1 second, sorry, I was not right there. Do you have any version of mixer for use in pharma continuous manufacturing processes? So not for use in a batch process, or maybe for a hybrid process, which would be an intermittent mini batch process, which can then dose into a continuous process like a pharmaceutical rotary tablet press?
As a question, the answer to the question is yes, you can do this. Typically, a single pod process is run as a batch process, and the reason for this is that typically you have got somewhere a vacuum drying process in your process steps, and this is almost impossible to do this in a continuous way, because to keep a system open within continuous feeding and discharging of product under vacuum atmosphere is very, very challenging. But when you think about tempering of product, when you think about granulation of product, when you think about inline milling, when you think about liquid addition to product and size reduction, this is of course possible in a continuous way as well. And we had also other customers doing things like, having a continuous production line, then putting in this line a vacuum dryer, running this more or less as a batch system, meaning you're collecting, let's say, for 1 hour, for 2 hours, the continuous product in a vacuum system to dry it as an intermediate batch, and then to continue on a tablet press. So this is possible. It wouldn't be a completely continuous process in this case, but it would be possible to sneak around this somehow. And most of these process steps I just introduced are also possible in a full continuous way, except the vacuum drying.
Okay. I think there is a so Jürgen Böcks is asking a second question. How do you avoid segregation in pneumatic conveyor conveying the powder mixtures to powder bin?
Yeah, so in my example where we did the granulation for the FFS tablets, the product is granulated. And this is already the answer, because we granulate the product to avoid segregation, really. So there's not a high risk that it segregates. First thing. Second thing is we've got partner companies doing the pneumatic conveying for us. In this case, it was Hecht, as you've seen, and they are expert and professionals in this, and they've got many different ideas, possibilities, how to avoid the segregation during the pneumatic transfer. It can be in a continuous way, it can be plug flow, it has to do a lot with the way how you convey the product. But as I said, in my use case or in my case study here, we granulated the product before, so there's no big risk of segregation. And if there is a risk, we need to talk to the handling experts.
Then there is another question. If you have small lab single pot machine for product development, Jorik Mardul is asking this.
Yes, we have the single pot systems are available in sizes starting at 5 liter and ending up at 55,000 liter. Everything in between is possible.
Okay. Then RD Cockle 2 is asking if this will certainly help to reduce the number of process steps and the transfer processes and cleaning which comes with it. A bit like production scale Thermomix. If you allow my analogy. 2 questions from my side. First one, is the system CI payable? Advantages of the single pot system are clear. Sorry, I think it's to the, should I read? I think it's an additional part of the first question. Should I read it?
Well, maybe just to answer the first question, yes, it is. So you can run the systems that can be equipped with WRP systems or CIP systems. And the big advantage of a single pot system is that it's typically designed as a vacuum dryer, so you can also easily dry it after wet cleaning.
Okay. And Johann Grün is also, he's like additionally saying advantages of the single pot system are clear, agreed. Could you also say something on possible drawbacks of the one pot system? Of course, not from a commercial viewpoint, but from a more academic view.
Sorry, what? Drop?
Single drop. Advantages of single pot systems are clear, agreed. Could you also say something on possible drawbacks of the one pot system? Of course, not from commercial point of view, but from an academic point of view.
I'm just wondering about the word drawbacks. I'm not familiar.
Drawbacks, it's drawbacks, Nick, drawback. It's DRAVBACKS, drawbacks.
Frankly speaking, I don't know this word. So if you can.
Oh, I don't know the word as well because I think it's a very technical word. Yeah. So I'm sorry for that. Disadvantages, drawbacks. Oh, okay. Sorry.
Disadvantages.
Rückschlag.
Oh, okay.
Rückschlag.
Now got it. I was not familiar with this term. Sorry for this.
Sorry for that. Me either.
The most critical point is always when we've got customers coming with an existing production process, for instance, with a high shear granulation, the fluid bed drying, they say, hey, we can save the fluid bed system. We're going to move to a single pot and we do the granulation and the drying in one system. And in many cases, in some cases, it can happen that the granules have a different size, different structure, or the granules are not strong enough to survive the vacuum drying process because there are differences between fluid bed drying and vacuum drying. And we had many cases in the past where we had to say, hey, sorry, we cannot transfer the process one-to-one from a high shear granulator and fluid bed system to a single pot system. Yeah, so not all products are capable of being transferred. So this is a matter of fact. But the only way to find it out is to try it.
Okay. We have 2 more small questions to go. Where do you see the limitations? RDK is asking.
The limitations are really, as I said, where the products are the limits, more or less. If a product is not, let's say, capable of being really granulated and dried in a single pot system, or if a special product treatment, if you really need, let's say, several milling steps, is not possible in the system. If the product requires, or let's say the product and the process is a limit. If there are certain things required which you cannot do in this single pot system, like if you need to complete, let's say, coding, like a tablet coding in the system, or if you say, I want to have densification of the product, which is not possible in the extent you're looking for. Well, as I said, if a vacuum drying is not possible because the granules are not strong enough for this, there are the limitations for a single pot system. Okay,
thank you. One last question, question. We have 1 more minute. What is a typical batch size in liters?
This is what the customer typically tells us, what's the typical batch size is. So from my experience for, let's say, cosmetic, food, and pharmaceutical industry, we did machines between 5 liter, and I think the biggest one was 3,000 liters so far. As I said before, we can do anything between 5 liter and 50,000 liter, but typical batch size for a single pot system would be in a range, let's say, between 10 liters and maybe 2,000 liters. This would be a regular batch size, but there's no limitation.
Okay. So I think all questions are answered. If there are any more questions, I'm sure Mr. Sander will be glad to answer everything. Even in the chat, you can contact him directly as well. And thank you so much. Thank you for the interesting speech and all the interesting information you have given to us.